So now we will discuss reshaping of arrays. Another useful type of operation is reshaping of arrays. The most flexible way of doing this is with the reshape parenthesis method. For example, if you want to put some of the numbers 1 through 9 in a 3 by 3 grid, you can do the following like this. Grid is equals to np dot arrange 1 dot reshape which is 1 2 3 4 5 6 7 8 9. So note that this to work, the size of the initial array must match the size of the reshaped array. Where possible, the reshape method will use a no copy view of the initial array. But with non-contiguous memory buffers, this is not always the case. Another common reshaping pattern is the conversion of a one-dimensional array into a two-dimensional row or column matrix. You can do this with the reshape method, or more easily by making use of the new access keyword within a slice operations. As now we will do here, x is equals to np dot array 1 2 3. Now we will write here row vector via reshape, row vector via reshape dot the Jupyter notebook keywords you can see from here. Code. Anyways, x dot reshape 3. It results in 1 2 3. So now row vector via new axis, row vector via new axis x which results in array 1 2 3. And now we will do with the column vector via reshape, x dot reshape 3. That results in 1 2 3 in a column. Now we will use the column vector via new axis x np dot new axis. Now that results in 1 2 3 as well. So we will see this type of transformation often throughout the remaining of the course. Now we will discuss array concatenation and splitting. So all of the preceding routines worked on single arrays. It's also possible to combine multiple arrays into one and to conversely split a single array into multiple arrays. We will take a look at those operations here, starting off with the concatenation of arrays. So concatenation or joining of two arrays in Numpy is primarily accomplished throughout the routines by np.concatenate or np.vstack and np.hstack. np.concatenate takes a tuple or list of arrays as its first argument. As we can see here, x is equals to np dot array 1, y is equals to np dot, sorry, my bad, and now we have to continue here. Now we will use the 3, 2, 1. np.concatenate, you have to be careful with the spelling. Concat innate, just like a senate, it's innate. X, Y. That results in array 1, 2, 3, 3, 2, 1. You can also concatenate more than 2 arrays at once. Z is equals to 99, print np dot concat innate, open the bracket again, we have an error here, type error, so let's see that. I got it. We will put the bracket here. Now we'll put the square bracket. Now x. C. Now we will put another bracket. Guess this works. Yes, 1, 2, 3, 3, 2, 1, 9, 9, 99, 99, 99. So np.concatenate can also be used for 2-dimensional arrays like this. Grid is equals to np dot one, 2, 3, 4, 5, 6. Yeah, now we will run this, concatenate along the first axis, np.con. The bracket, square bracket open, grid. Now this results in this. T-type object, list 1, 2, 3, and it goes on. Now let me see that if we put the square bracket here. Now let's run this. Now let's run this. This will result in this. So we had an error It was not an error. It was like it was not a cool answer. What we wanted that we actually wanted this output. Okay, so continuing along that now, concatenate along the second axis in which 0 is indexed. np.concatenate grid axis 1 1 2 3 1 2 3 4 5 6 4 5 6. So for working with arrays of mixed dimensions, it can be clear to use the np.vstack vertical stack and np.hstack, which is horizontal stack functions. X is equals to np.array grid now put another bracket. Now vertically stack the arrays. Vertically stack the arrays. np.vstack x grid. That results in 1 2 3 9 8 7 6 5 4. So now horizontally stack the arrays. We will do y is equals to y is equals to 99 np.hstack grid y. This results in 9 8 7 99 6 5 4 99. Similarly, np.dstack will stack arrays along the third axis.